Hi, this is Junaid, Neurological Care Stroke and Epilepsy Specialist. Today I'm going to be presenting on artificial intelligence and neurological disorders. I'm very grateful to be invited to speak on the prestigious course, which is the 18th Neurology Certificate course from Al Khan University Hospital. Being medical advisor, consultation for many different companies and on artificial intelligence that I can't list over here, but these are generally where my current positions are in terms of employment and contraction and some of the independent work that I'm doing in the field itself. Now, this is a very big topic and I cannot boil an ocean. What that term means is basically that this is a vast ocean in which we have to get into. So the objective is basically to get as much information as you need in terms of clinically relevant artificial intelligence and getting the basic concepts around it. And then you will improve upon it more and more your knowledge in terms of looking at artificial intelligence articles, YouTube videos, etc., and going from there. My videos are more and more going to be concentrating on artificial intelligence. So make sure you follow me in terms of my YouTube channel, my blog, and of course Neurology Pocketbook as well. So here's the issue. Change was always changing, right? It's never been that issue, right? I mean, at the end of the day, the acceleration of change itself has been accelerating for the past decade. What artificial intelligence is that it changed from logarithmic to algorithmic change. What's the difference? The difference is that if there's an algorithmic change, let's say in terms of YouTube algorithm, it affects 2 billion people, TikTok, 3 billion people, Facebook, 3.5 billion people. It's ridiculous the amount of change that you can produce when you change an algorithm. I mean, we always have heard this, right? I mean, zamane ke andaz badle gaye, naya raag hai, saaz badle gaye. This has been an Allama Iqbal's quote that we keep quoting in Pakistan, especially for a long, long time. But believe it or not, the change itself has changed. Interestingly, this 1922, exactly 100 years ago, Allama Iqbal was given the title of Sir. So interestingly, we have been a 100-year journey and we are still talking about change as change. And believe it or not, this time it's very significant. Now, publications in artificial intelligence have been increasing at an alarming rate. As a matter of fact, the peer-reviewed publications that were coming in artificial intelligence is on a rise constantly. And more importantly, it's not just coming from the academics. Believe it or not, more and more publications that I read personally are coming from Facebook and Google, because those are the technology papers that I have to make myself aware of, because more and more changes that these companies are coming up with, and they are doing real good publication, and sometimes it's open source, open access. So first of all, I need to know them personally, but just letting you know that academia is truly falling behind in terms of research publications in artificial intelligence. So if you want to follow that technological curve, you need to follow corporate publications as well as academic publications as well. As far as neurology is concerned, as you can see, every single year there is more and more increase in terms of publications in neurology. These are only specific clinical application neurology publications that we are talking about. And you can see that from 2018 to 2020, there's clearly doubling every year in terms of publications in neurology is concerned. All the other places, as far as subspecialties are concerned, there has been publications, general publications. Radiology is one of the top publications where you would see artificial intelligence being applied to. However, cardiology and neurology are neck to neck. And if you see, COVID-19, of course, was a little higher in terms of publications, which is probably going to fall off now, given that we are going over the hump of that. So artificial intelligence application has been used in every freaking subspecialty, and neurology is not behind. As a matter of fact, neurology is right up at the level of cardiology in terms of publications as well. Now, the publications are divided into 5 major categories. And the issue here is that why is that those areas being concentrated on? It has nothing to do with clinical application. It has everything to do with availability of high quality data. Look, Alzheimer's, Parkinson's, which are the neurodegenerative and dementia disorders, have had multiple years of funding from the government in terms of FDA, NIH, NIHSS, NINDS. All these major federal funding has been going into dementia because Alzheimer's has been a big problem and we need newer solutions. All those data that has been collected in last 10 years from imaging, biomarkers, everything can be churned up through artificial intelligence better, faster, because we have availability of high quality data. However, The application, the true world application in artificial intelligence is in stroke. That's we're going to come into in the next few slides. So you have to distinguish between publications in terms of what academia is moving towards and real life applications. So the reasoning behind it is not just the publications itself. The reasoning behind it is basically availability of high quality data. So what it tells me, everything, is that AI is developing super fast. As a matter of fact, when you're going to look at it in terms of both technological aspects and in terms of clinical applications, we are seeing more and more applications that are getting FDA. I'm not going to use the word approval. So that's another big thing, because FDA granted, FDA access, FDA listed, and FDA approved. However, for now, we're going to see that AI is developing fast. Its adoption has become faster. As a matter of fact, more and more industry leaders and more experts are proposing that, especially in healthcare, artificial intelligence should be the way to go. Especially with HIMSS 22, if you look at the news that came from there, more and more leaders are going to be open to adopting artificial intelligence. Now, why now? I think there are multiple reasons, and this is a whole chart we can go into, but given the time, I'm going to just talk about two things. Number one is the key issue is compute power. It has become significantly cheaper and is significantly accessible in terms of compute power, because we can do compute over the cloud, and even our devices are getting much and much powerful in terms of compute. Second big thing is data, and not just data in terms of slow hard drive spinning drives data, it's a solid state drive, which is the flash drives. And the reason behind is that we need faster drives sometimes so that the data can go in and out pretty fast within the computer engines. That is decreasing in cost. So two major, storage and compute power, is decreasing in cost significantly. So the accessibility, for the barrier to entry, has gone significantly low for these studies to come up. And therefore, more and more studies are being done, and more applications are being done on artificial intelligence. Before we get into it, I always remember that we need to talk about why is it important. You know, you can apply artificial intelligence in any data, right? I mean, let's say I'm going to pull out some of the tweet data from myself and then put artificial intelligence in it. Great, right? I mean, we can do that. But the more important thing is to always find out why we want to do something, especially in terms of technological applications. So the key issue with neurology is what? Latency of care. Time is brain. So one of the things that we want to apply artificial intelligence in situations where we can decrease the time for treatment, stroke, hemorrhage, subarachnoid hemorrhage, etc. The second big issue is that we don't have a troponin. Like, I mean, that would be fantastic, right? If you can get a blood test for Alzheimer's. We can't. If you had that, that would solve so many issues, because we can have early detection of Alzheimer's and then early intervention of the Alzheimer's. We can't do that. So we need significantly new biomarkers in terms of imaging, in terms of MCI clinical biomarkers, and in terms of genetic biomarkers, and we probably need to combine them. So the question is that we need to make sure that we have new forms of biomarkers that could only be achieved by large data churned by artificial intelligence. We're going to continue to have lack of neurologists. I mean, Pakistan has a significant lack of neurologists. Then on top of that, we also have a long tail of these patients that are chronically going to live with neurological disorders, either Parkinson's, Alzheimer's, stroke, etc., epilepsy, all of these things. We're going to significantly see a growing population of older and older people around the world, and they are all going to get, basically neurological problems, and we need to help them. And this is what I keep telling my cardiology folks, is that thank you for making sure that people are alive so I can take care of their neurological problems, because that was the last century, to be honest with you, where cardiology was at the boom, in which heart problems were the issue and people were constantly getting heart attacks and dying from it. But in neurology, now they're living well and unfortunately being afflicted by neurological disorders. Now, before I get into the direct applications of neurology, let me just give you some conceptual basics of artificial intelligence. First and foremost, you need to understand that artificial intelligence is not a technology. It's a technology enabler. What that means is that any type of data that you're going to generate in either through blockchain, DNA sequences, Internet of Things, healthcare IoT, autonomous mobiles, robotics, any situation in which you're going to generate data and you need to have run a simulations of multiple possibilities, you're going to need artificial intelligence. So this is considered what we call general purpose technology. It is not considered one technology. So therefore, when you have a technology like general purpose technology, like artificial intelligence, you do not compare it with just DNA sequences, because that's one part of technology that cannot be applied in finance. But artificial intelligence can be applied in finance, healthcare, economics, education, everything. So therefore, artificial intelligence is to be compared with electricity. So it's artificial intelligence is as important as electricity in terms of its impact, because it's a general purpose technology. And that's why there's such a huge buzz and everything. I mean, there's a lot of buzz, so don't get into it. But at the end of the day, that's where the real difference is in terms of just being a technology or being a technology enabler. Now, second thing that you have to understand is like the first question, why do I need to know AI? I'm going to give you many examples of artificial intelligence being used in clinical impact. Exactly the same way that you have learned mechanism of actions of drugs all your life, right? Like this is topiramate, this is Keppra, this is a mechanism of action, this is the half-life, this is what. That is a tool that you use to help your patients. Exactly in the same way you're going to be using artificial intelligence in the future. And exactly in the same way you need to understand some basics, some mechanism of action for artificial intelligence to make sure that you're appropriately applying those tools for your patient care. So do not think that artificial intelligence is something you do not need to know. It is now as important as learning biochemistry in pre-med and then biochemistry in med school or anatomy or physiology. There should be courses on data sciences and artificial intelligence in medicine. This is not the time. I can give you some more big references on where at least universities in the US are going. If you want to check out Northwestern University, just added a complete course on data sciences and artificial intelligence in their medical school curriculum. The reason is this. You are going to be taking care of your patients using these tools. So you need to make sure you understand some basics, at least enough that you currently know what the mechanism of action for some medicines are, and choose accordingly which medication you're going to use and which you're not going to use. Exactly in the same way you have to start using artificial intelligence, which software stack you're going to use and which you're not going to use to help this particular patient. So that's why it is extremely important, and this is your role as a physician to understand this in the future, and the future is not that far, as I told you before. Now, when you're talking about artificial intelligence, what we are talking about is machine learning, and that's not a good term that I use the word artificial intelligence, because that's a general purpose technology, and there are different ways to colloquially tell something, and the other way is not to say it. Generally, the best term to use is machine learning, and one of the key issues with one of the subsets in machine learning is deep learning. So let's talk about two things we're going to be talking about is machine learning and deep learning. Machine learning is basically that when a machine basically learns from examples, and deep learning is basically in which we are not giving too much labeled data, and more exceptionally large amount of data is added in terms of deep learning. And therefore, when you're trying to explain, so colloquially we use the term artificial intelligence, which is, to be honest with you, not the right term. The term we should be using is machine learning. And whenever we are referring to artificial intelligence, especially in healthcare, we're talking about machine learning. Machine learning has another subset called deep learning. And deep learning is basically when you have more higher forms of learning that are compute intensive and data intensive. In that regard, we have to see that when you are moving from machine learning to deep learning, there's massively increasing amounts of requirements for data and massively increasing requirements of compute power. However, we lose one key issue. We lose explainability, because in machine learning, we are giving them at least some sort of rules to go back, and then we can explain that how that result was coming up to. But in deep learning, that is not the case. Let me explain further. So what is the difference, right? I mean, what's the freaking hype about in terms of artificial intelligence? We have been, have human intelligence for years and years, right? So we have been programming for years. Like, it's been approximately 50 years of coding and programming that has been going on. How do we do that? Human coders spit out a lot of instructions and rules. That rules and instructions basically create a program, something like this, in which there's video uploaded on the YouTube, etc. And those instructions are basically packaged and then go into it. What's the difference is that we no longer want human to code. Data codes. We basically do not give them instructions. We give them examples. Let me rephrase it. There are 10,000 cat pictures and we can tell them, okay, do something about it. The computer will never learn, because no matter how many times you have instructions to divide that from between dog and cat, it just never works. This is a completely new paradigm in which you do not give instructions to the computer. You give, okay, here are a million pictures. this is the dog, this is the cat, and then learn from it. And here's another 10,000 more where you're going to be able to distinguish between the two sets of data and test them. We'll come to that in a minute. So the key difference is human codes to data code, instructions to examples. We give tons and tons of examples to the computer, and that's how it learns. And that's, to be honest with you, is the basis of human learning as well. Another big difference is that reasoning in artificial intelligence. Look, what we have been taught about is deductive reasoning. That's how we run virtual clinical trials. That's how we move on in terms of scientific discovery, scientific validation. What do? We have a theory that, topiramate helps with the headache. Then we create that into a hypothesis. Then we create virtual clinical trials, divide patients into two arms, we do observations, and then we confirm that if our hypothesis was correct or wrong. This is our current methods of thinking, and this is what we call Aristotle or deductive thinking. Sherlock or inductive thinking has been that we don't care. We just say there are tons and tons of millions of records and here, and then just find out patterns in it, and then see with the patterns if we can create some more hypotheses, and then we create theory. So for example, there are 1 million epilepsy patients who are on topiramate, and then we saw that they also had some 10,000 of them had migraine, and we saw that those patients who were on topiramate had a decreased headache frequency because they were on topiramate. That's artificial intelligence, because you're putting in a lot of data which does pattern recognition and gives you a theory rather than the other way around. So artificial intelligence is inductive reasoning. Artificial intelligence starts with observation, examples. In terms of deductive reasoning, it starts with theory and confirmation. So that's a completely different way of looking at things. And then you will have to do a complete clinical trials as well. But what AI can do is get you there faster, can get you there smarter. And that's where drug discoveries are being done through artificial intelligence. That's exactly the pathway that they go into, which was a different pathway for what we were doing before, because we were now able to select compounds much faster, much easier, much smarter to do for clinical trials through the inductive reasoning process, which is based, artificial intelligence is based out of. And this is what I was talking about, practically speaking. When you have an original data format, you turn it into a training data set, into a testing data set. Sometimes you do have a validation data set as well in between to hyper-tune your parameters. But either way, the logic remains the same, that you take a tons and tons amount of data, separate it out into training data and say, okay, these are labeled data, these are cats, these are dogs, and then these are unlabeled data in which, I'm going to test how do you perform in identifying those images. The other thing you need to know is what's the real difference between statistics and machine learning. You understood the reasoning behind artificial intelligence is, which is different than what we have been doing, and that's why it's harder, especially for physicians to get that, because we have been ingrained into clinical evidence process in a different way. Now, and then the tools that we have been using for years and years for clinical research has been statistics. In statistics, the whole goal is what? Relationships. To understand that if this particular situation correlates with this particular disease, smoking to cancer. So it doesn't matter. It's still not causality, right? We don't know if it's truly causing, right? It's at the end of the day, it's a relationship that we have identified increased risk of cancers and stroke in smoking patients. And then we infer from that particular statistics. And that's why it's very explainable, because we know we have run different kinds of variations of statistics, and then we came to that particular conclusion. And the artificial intelligence has nothing to do with that. Artificial intelligence is all about prediction. I'm sitting on a card table and I want to know what the next card is so I can bet something different. That is it. The whole purpose of artificial intelligence is to predict. That's where the real magic comes in. If there's going to be a financial decline, or if there's going to be this patient is going to develop stroke in the next 10 years, if this patient is going to develop heart attack in the next 5 years, we have lots and lots of data. We have millions of examples, and we have seen different areas in which these patients perform differently. And now we can, through a significantly precise way, predict where that patient is going to fall in the next 5 to 10 years, and you can change the trajectory. That's the key thing, right? We are always responding, quite frankly, most of the time in terms of disease management. And this is the paradigm shift in terms of disease management, to moving from treatment to prediction and prevention. So that's the key difference between statistics and machine learning, because that's where we are going into in terms of artificial intelligence. And it is truly based on human learning, right? I mean, if you look at the human learning, I mean, if I look at one of the cat, what happens? I have the one neuron that goes into and then connects to different synapses to my visual cortex and comes back and tells me, okay, this is a cat. And exactly in the same way, artificial neural networks are designed. It takes one of the images, divides it into multiple areas, and each single pixel is sometimes regulated in terms of what it is, and then eventually you get a complete classification if this particular CAT scan or MRI has an infarction, tumor, or hemorrhage. So what we're seeing is that's why we call it artificial intelligence, because we are trying to mimic human intelligence, and that's where the beauty of this whole thing comes in. Now, another thing that you need to realize as far as the difference is concerned is that what is the difference between an algorithm and artificial intelligence? Look, people don't understand. They use the word algorithm all the time. And by the way, we have been using algorithms for 50 years. This is a basic algorithm for hypernatremia that we have used for many, many years, right? I mean, I'm assuming everyone has used that. What's this? This is basically a rule-based algorithm in which what you have done is basically you have sodium for this, then you go true or pseudo, and then you go to next step, then you go to the next fork, then you get to the next fork, order some studies, and then move forward. This has been a rule-based algorithm, and as a matter of fact, to be honest with you, medicine runs on these rule-based algorithms. If you have a book with rule-based algorithms, you can give it to a first-year medical student, and he can get you somewhere in terms of moving the patient management forward. What's the difference then when you have artificial intelligence? You see, the rules are not made. There are no instructions. We give 1 million records to the patient and tells them, well, this is hyponatremia. What do you think it is as far as diagnosis is concerned? With the 1 million examples, it finds out, okay, if the patient has these characteristics, then it's going to fall into this bucket. These characters fall into this bucket. These characters will fall into this bucket. Creates its own database algorithm. And then when you give another 10,000 new testing protocol, then it can predict for you where that patient is going to be. Do you understand? Now I'm hoping that this circles in, because it's hard to put these concepts into one sort of lecture. So this is the whole idea behind it. Who will benefit from loop diuretics? And you're basically going to see, okay, the data is going to basically tell you who is going to do that, rather than you creating a rule-based system. Now, in the beginning, there will be more hybrid approaches, right? I mean, I'm going to basically use natural language processing to figure out all the data from the EMR. Then I'm going to have part rule-based approach, and then I'm going to have something else. So there are different hybrid forms of care pathways that are going on, but eventually it's going to evolve into one care pathway. So in algorithm versus AI, data codes, not rule codes. Now, one of the other things that are truly about artificial intelligence is that if there's a continuous stream of data, those rules the word rule may still be the way the artificial intelligence predicts can change, because there is a continuous stream of data, and as the data changes, the artificial intelligence algorithm itself can change, which is very different from rule-based, because rule-based gets stuck, right? This is some expert came in or whatever, thousands of different scientific observations that created that rule-based algorithm. But the benefit of artificial intelligence is that it can continuously learn, and that is the key thing. However, that is not currently present in medicine. Let me give you an example. This continuous learning is what YouTube does, Facebook does, Twitter does. There's a constant new trends, and then they shift their algorithm models accordingly, and then prevent from whatever reason, and you can introduce some of different ways in which to introduce some bias, and that's one of the ways that they work. But what we want to do is that we should in medicine have the same opportunity, but unfortunately that's not true. To date, I am not aware of any medical algorithm that is constantly learning. They have learned from the data. That algorithm is static, is based on the data, and is applied. But it is not constantly learning. And the reason behind it is that there's a significant amount of clinical data shift and clinician data shift, and there are major issues. Let me give you an example, because that would be easier. Look, we have a fantastic algorithm for sepsis, for predicting sepsis. And as a matter of fact, it worked beautifully before COVID. But after COVID, the sepsis was completely different, because most pre-COVID sepsis was bacterial in origin, but post-COVID, we had viral sepsis. And those viral sepsises were very different. For the computer to predict those viral differences, it needs new forms of data so that it can predict much better. We didn't do that because it's not continuously learning environment. We don't have it because of multiple reasons, but for now, that's the biggest issue because we do not have a continuously learning environment. That sepsis algorithm freaking broke. As a matter of fact, the company has to retract it. So that's the key issue in terms of medicine, and which is the biggest issue is the data, high quality data that you can process in real time to produce predictions in real time that could potentially be shifting because of environment, country, genetic background, etc., etc. So that's the big issue why we do not have continuous learning of data and continuous learning algorithm, which is the true form of machine learning in medicine. So that's what another vision. And that's one of the key issues another issue is that keep asking me, will AI replace physicians? Absolutely not. Now it's already, the current state, if you look at it, it is basically combining human and AI in terms of very narrow tasks. So if you have a narrow task, CT brain hemorrhage or no hemorrhage, yes. But when I look at a CAT scan, I mean, it's not just like if it's a bleed or not. I mean, it's a 70, 80-year-old female that has significant atrophy. Why the hell? So I can talk about dementia possibly with the same patient while I'm talking about Alzheimer, talking about stroke. Where I see that the patient has calcification in places where there were no calcification. So in a complete narrow task, artificial intelligence is right there. In computer vision, and I mean, I'm going to talk about, there are definitely places where artificial intelligence significantly lacks, and there are places where artificial intelligence is better than physicians. However, in future, we're going to see that since we're going to have more and more high quality data added, we are building data pipelines in which high quality data is going to be input for continuous learning. We're going to see that data, the process shift in which in more and more tasks, artificial intelligence is going to get better and better from humans. I mean, it's quite a while away, about 20 to 30 years away in terms of truly seeing that massive impact. In medicine, there are definitely areas in which artificial intelligence is going to be the standard on which physician overlay reading will be there. And this is where we come in. AI will not replace physicians. However, physicians that use artificial intelligence will replace physicians who do not. That's something literally, if there's one slide that you have to take care of is this, you have to learn it exactly as you have learned everything else. And secondly, initially, at least in the majority of cases, you're going to see that artificial intelligence and automation that is added is basically allowing you to have better decision support in terms of faster care, low latency of care, improved care outcomes, etc., etc. But at the end of the day, you have the helms of the control in terms of patient management is concerned. Think of it as the horse, or ski lagam jo hai, wo lagam physician ke haath mein hai, but the horse is getting better the whole time ever. I mean, literally, it's going from a horse to now a Ferrari. So in terms of moving, in terms of improving accuracy and improving predictions. So now we come to development of artificial intelligence. As I talked about data, look, the data is massively improving. As a matter of fact, there's 1/3 of clinical data in production. So if there's 100 data points are created, about 33 of them are coming from the healthcare industry. Healthcare is a massive reason for expanding data in the world. And we are expanding data significantly. I mean, YouTube videos, etc., etc. So we are having a lot of data that is coming out, but healthcare still creates a lot of data. And unfortunately, that is multidimensional data. What I mean by that is that there's disease data, radiomics, genomics, biomics, and then there's health data, which we are, creating with our smart watches and ECG machines, voice analysis, etc., etc. And then there's claims data, with healthcare industries coming up with it. Healthcare insurance is coming in it. And then, of course, we have clinical trials data, bio data, and clinical registries data, and those can be pulled on, which is important. First of all, there's a lot of volume, but unfortunately, the biggest curse in medicine is that it's dimensional over time as well. So my body metabolics is very different when I was 20 years old. I mean, I'm becoming an old man now. So clearly the metabolics have changed. So over time, the data characteristics change. So that's where the curse of dimensionality in healthcare comes in. And then more importantly, more and more convergence is happening, right? I mean, as I said, we have more digital therapeutics are coming up, which is going to create new forms of data. We're going to have new forms of genetic analysis, which creates more data. Then we have new manufacturing done, so there was more data. So we're going to have more and more data coming into the pipeline. And no matter what you do, you're going to need artificial intelligence to churn it, period. There's no other way around it, because it's just impossible for anyone to take that into a data science and then make sense of it, because you have to have that data to be done. And that's where another thing comes in. You do have to have a purpose, right? You just don't collect data for no reason. You collect data to process it. That's key thing. That is why the development of artificial intelligence is going to happen in stacks. So I don't know if you have any brother or sister in software services, but you should talk to them. They talk about software as a service, SaaS. That's the key term. Software as a service is basically you find a small problem and you develop an automation solution on it, and then you apply it to the big stack. And then you another problem, big stack, another problem, big stack. And it's exactly the same way artificial intelligence is developing in medicine. I have a problem in terms of artificial in stroke. I have medical imaging analysis through computer vision, one stack. I need natural language processing to process patient reported data, or also clinical reports. I have another transfer and management issue that do that. I have another stack of genomics. All these stacks are currently going to be in development on different stacks, and these are software as services. Eventually these software and services are going to become immature, and then when they're going to become mature, they're going to combine, and when they're going to converge, that's going to turn into a full artificial intelligence that is going to be more and more usable. And believe me, this is disruptive and can happen suddenly, like the Kodak moment, right? I mean, nobody's using plain films anymore. Everyone's doing digital photography. And I have another lecture on convergence of virtual care and artificial intelligence, because the virtual care is now becoming a very important part of producing ground truth, valuable, confirmed, validated data in clinical. So therefore, if you're interested in looking at convergence more, you can look at that lecture. Now, there are three different pillars of artificial intelligence. One of them is computer vision, which goes about digital pathology, etc., then predictive analytics and natural language processing. So let's go into that. So computer vision is all about neuroradiology in your terms and neuropathology. And then in terms of video analysis, if the patient is walking, you can see if the patient has stranded walk, is it the spine issue, is it the multiple sclerosis patient, in which we are using video analysis to quantify that walk, and how the new medication you're going to develop is going to improve. So we're not going to talk about virtual clinical trials right now, but the idea is that image and video analysis, computer vision. Then we have predictive analytics, and this is where the decision support and trend analysis comes in. Simple pulse oximetry is coming through the ICU. You can say that if the pulse ox is changing, is the patient developing high increase in intracranial pressure, or is the patient has different heart rates and blood pressure monitoring are changing? Can you predict, at least sometimes, as a matter of fact, there are studies that have predicted a sudden development of cardiac arrest in sick sepsis patients up to 15 minutes earlier. So that's where the prediction trend analysis come in the predictive analytics portion. And then finally, natural language processing. Natural language processing is the most exciting and the most important feature. As a matter of fact, that's why Google shines a lot in terms of its prowess in artificial intelligence, because their whole thing was behind search is natural language processing, all the word data on the internet, and how to collect, accumulate, and create wisdom from it. There are two areas in it. One is speech and the other one is text. Speech is text to speech, speech to text. All of them use artificial intelligence. And as far as text is concerned, classification of that, extraction of that, summarization of that, translation of that. As a matter of fact, IBM Watson was summarizing automagically some of the cancer trials, and while the patient is being seen, and when you search on that, they would recommend which clinical trial is applicable to that particular patient and pull up a summary of that as well. So clearly there are different areas where there are applications, but this is a sort of a chart for you to understand what different areas of artificial intelligence are and what they are concentrating on. And we talked about data and convergence. Data. It is all about data. And data is literally the new oil. Nobody talks about Enron as the most valuable company. We talk about Google, Facebook, Tesla, Amazon. And the reason that Tesla is the most valuable company is because it doesn't have a freaking four wheels that is better than any other car, because it is not a car company. It is a data company. And one of the key things that you need to keep working on, and this is one of the most important papers from last year, is that everyone wants to do the sexy model work in artificial intelligence, and I want to create models and then turn algorithms and everything. Data work is the most important work. If you have a beautiful data pipeline, you will have golden area to develop artificial intelligence, to develop ground truth. And once you have that, you can be amazing in terms of artificial. So data work. It is not just modeling and all that. To be honest with you, it's getting very easy. One of the other things you have to remember whenever you provide automation to anything, automation is like a catalyst. If you have a process that is garbage, it's going to catalyze garbage into more garbage. And if you have an area in which you are efficient and you put in a catalyst, then that efficiency is going to be expanded as well. So it's very important that wherever artificial intelligence is applied, it is applied in a process that has been optimized and efficient before you apply artificial intelligence. Because if you don't, then that AI is going to be a bigger problem in terms of where it is, because it basically is a tool, it is a catalyst. Anytime you have that sort of automation, make sure that you have that silk smooth out before you make applications. Whew. Now let's get to artificial intelligence in neurology. We're going to talk quickly about two major things. One is stroke. You see, stroke is 861 billion problem, huge issue. There's increasing incidence, increasing deaths. People are living with it more and more. As a matter of fact, if you literally do 1 minute delay, you are basically killing 1.9 million neurons and 14 billion synapses. And if there's a fast progressive stroke, you can lose a limb completely in 5 minutes. We definitely need to reduce time, right? If you're not going to reduce time, we're going to have a big issue. And that's where artificial intelligence comes in. And this is one of the earliest application of artificial intelligence that is commercially available and viable. There's a difference. Commercially available, clearly this is FDA approved. People have seen it. People have applied it. I use this software every day in my life when I'm providing stroke care. And it is getting reimbursed. So people are getting paid for the hard work in artificial intelligence they have done, because it's just not about academics. It's about producing a product that is commercially viable and reimbursable. So there are multiple software packages. This is one Wassay. I don't know if you're aware of Dr. Adnan Siddiqui and Amir Hussain. They are fantastic people here in the US. Amir is from Egypt and Adnan Qureshi is from Pakistan, who has done this study and showed that artificial intelligence decreases latency to care by 66 minutes. Think about the number of limbs you can save and lives you can save with that, because you can get to the patient faster and earlier. If you don't have a thrombectomy center, it's bullshit to apply it, right? You have an efficient system to get efficient results. You just don't put artificial intelligence where you can't create a difference. So remember that. But at the end of the day, that these are the value that artificial intelligence is bringing. We can see it in intracerebral hemorrhage dissection. We can automate it intracerebral hemorrhage detection as we want. We can have significant amount of commercial softwares that are available. This is the list that is there, and you have to find the right problem to find the right solution. This is a complete video that I did. Make sure you look at it in terms of role of artificial intelligence in telestroke and how it becomes more than life in terms of decreasing the latency of care itself. And this is the paper that got published about the same thing in terms of role of artificial intelligence in stroke and telestroke. The second big reason is biomarkers. I told you about it because one of the key issues in prediction of neurological disorders is to have something that I can have to diagnose the patient, and more importantly, not just the diagnosis, early diagnosis, so I can make a change to predict how the patient is going to move, and then any intervention, early intervention that can be done to correct that bad pathological pathway that is moving forward. It is most important in terms of stroke and in terms of Alzheimer's and everything. And we are working on it, right? It's not like we're not stopped working on blood-based biomarkers. We're looking at hemorrhage, and we're looking at subarachnoid hemorrhage. We're looking at CSF analysis in some of these patients to find lab-based biomarkers, blood-based, serum-based biomarkers for these patients. However, it is becoming harder and harder, and we have to produce different methods of doing it. And one of the methods is using deep learning, artificial learning, in a multimodal way to predict early if there's anything going on. And one of the best applications has been in Alzheimer's, in which what we're seeing is that we can combine imaging, genetics, and clinical test data. This is not available commercially. This is currently in research only. However, what we are seeing, the trend going forward, is that when we have combination of these different data sources, I can predict Alzheimer's at the age of 55. What am I going to do with it? Well, currently nothing. I mean, there's only one drug that is available, which is highly controversial. But at the end of the day, if I have to develop a drug, I cannot give it to a person who already has advanced dementia. What am I going to do? The brain is already problematic. We need to early intervene. So the minute I'm able to have an authenticated, clinically validated, digital or multimodal biomarker, I can intervene with a new medication, study that medication, and see how it goes. So we're going to see that more and more as far as biomarkers are concerned. Now, I have all of this and more in terms of my courses that are coming as far as how to choose a medical specialty in this new post-pandemic digital healthcare era, in which I'm going to talk about artificial intelligence, virtual care, and advanced practice providers. And I'm going to be giving out a total of 100 participants a significant discount in honor of Dr. Wassay. So I'm going to send it because he is a beacon of neurology in Pakistan, and I have been impressed that how he has managed to do all this all the time. So I'm going to send it to him, and he can distribute the codes to anyone, and people can take this other course in much more detail as far as artificial intelligence, virtual care, and other things like lifestyle considerations, financial considerations, etc. So it's being built. It's going to be available next month, and I hope to see you there as well. Another thing that you might want to help me with is about neurologypocketbook.com. You can go, there are multiple chapters that I'm adding about digital neurology in terms of what is digital health, what is mHealth, mobile health in neurology. And then there are chapters on digital education in neurology, artificial intelligence in neurology like cerebral ischemia, and this is all open access. So you can copy paste it, put it in your presentations, etc., and maybe contribute if you want to. This is the website, and then of course everything that I do is on one LinkTree, including Twitter, etc., all that. Thank you so much for your help, and I'm very, very grateful for your time. If you save a life, it is as if you saved the life of mankind. Please make sure you like, comment, share, and subscribe to my YouTube channel and my newsletter. If you want to get in touch with me, the best way is to go through Twitter or via LinkedIn. Also make sure you follow the Academy website for regular updates. Thank you so much.